Hi guys, I hope you had a good spring break. I've got a couple of things I got to take care of today, so I will see you on Tuesday. For now, you're going to be taking notes on lesson 10-1. We're going to start graphing quadratic functions. I want you to take notes in your notebook. However, there are some graphs that you're going to need to do in your book. Okay? I'm on page 175 so that you can follow along. You need your notebook and your book. Okay? So let's start by talking about quadratic functions. When we graph what is called a quadratic function, it's going to be this U-shaped thing right here called a parabola. So a second degree polynomial, so second degree, we've got 2 as an exponent right here, is a quadratic polynomial which has this related function right here. Okay, so a quadratic function has this form of y equals ax squared plus bx plus c. That is our quadratic function. We have it right here. Probably write this part in your notes. Okay. So it's called a quadratic function, and this is the formula. Okay. A is not allowed to be 0. So a cannot equal 0. The function, or the graph of a quadratic function, is called a parabola. That's what we call that U-shaped graph, is a parabola. Parabolas are symmetric about a center line called the axis of symmetry. So basically, if I cut this thing in half right here, on that red dotted line, it's symmetrical. It is the same on both sides. Or if I took this and I folded it in half, it'd be like a butterfly. Remember the butterfly projects that we did in elementary school? So axis of symmetry, every point on the left has the same side on the right. So if you look right here, I got 1, 2. I'm 2 away from the center line. If I go 2 away from the center line, I have that right there as well. Okay, so it's going to be the same on both sides. The axis of symmetry intersects a parabola at something called the vertex. The vertex is the tippy point. Parabolas can open up like that, where this is going to be a minimum, or parabolas can open down like that, where the vertex is going to be the maximum. Okay, so this one would be the minimum. I can't spell. And this one would be the maximum. We've done that before. Okay, so remember it's either the lowest or the highest point. When a is greater than 0, so when we're looking at this, when a is greater than 0, it's going to open up. And when a is a negative number, it is going to open down. So we would have the minimum or the maximums, okay? So the leading coefficient determines the end behavior of a quadratic function. So it determines whether it points up, or opens down. Let's get right on to it. We're going to do example 1. Okay, so we're going to identify the characteristics of graph with the x-intercept. Okay, so identify the axis of symmetry, the vertex, and the y-intercepts. So the equation of the axis of symmetry. So let me find it. Where's my highest point? Right there. If I cut this graph in half right here, is it exactly the same on this side as it is on this side? It is. So where this line that I drew, where it crosses the x-axis right here, that is going to be my axis of symmetry. So x equals -2 is my axis of symmetry. So the vertex is located at that maximum height up here. So what is that? I've got -2, 8. So the vertex is -2, 8. Next, the parabola crosses the y-axis. So here's my y-axis. It crosses right here at 0, 4. So the y-intercept is going to be 4. Lastly, as x increases or as x decreases, what's happening at the bottom? At the end of the graph, y is decreasing. That's how they want to do it. So that's the end behavior. Down by the arrows, as x decreases, y decreases. As x increases, y is still going down, it's decreasing. Okay? Go ahead and pause your video. You're going to do this check on your own. So my axis of symmetry, find that top point and draw a line. Boop. Where does it cross? X. It crosses X at 2. That's my axis of symmetry. The vertex is that highest point. It's going to share that 2 for X. What is Y? 16. The y-intercept, here's my y-axis. It crosses right there at 12. As X increases, Y is decreasing. Decreases. As X decreases, so X is getting smaller, what is Y doing? It's going down, so it is decreases again. Very good. Let's move on to example 2. So now we can identify the graphs with no x-intercept. See here, this graph never touches the x-axis, but we can still figure it out. Okay, let's start with the axis of symmetry. So, let me draw a line straight down the center. I followed my y-axis there. So x is 0 because it crosses the x-axis at 0. So it shares the x as 0, but what is that vertex? I've got 1, 2, 3. So 0, 3 is my vertex. Parabola crosses the y-axis, still at 0, 3, so the y-intercept is 3. It's that y value. This parabola is opening what direction? It's opening up. Okay, so as x is increasing, y is going up, so it increases. As x is decreasing, it's going down. Y is increasing. It increases. Okay. Pause. You try this, check on your own. Are you ready? So the axis of symmetry, I want to cut it in half. Here's where it looks like it's the same on both sides. There's my line of symmetry. Axis of symmetry, so what is x? I went between -2 and -4 is going to be -3. Okay, so I'm going to stay with my -3. My vertex is this tip right here, so I've got -3. This is going to be 3. So -3, 3. My y-intercept, here's my y. Where do I cross? Right there at 12. So my y-intercept is 12. You might see my cat here in a second. He's trying to pounce on me. As x is increasing, x is getting bigger, what is y doing? It's going up, so it is increasing. As x is going down, x is getting smaller, y is increasing. Okay, here we go. We're moving on. We're going to learn about graphing quadratic functions. So what happens if they don't give you the graph and you have to graph it yourself? So I already told you about the standard form of graphing a quadratic equation. It's the ax squared plus bx plus c. A cannot equal 0. Okay, so if I give you this one, then 3 is a, -2 is b, and 9 would be c. Okay, so you just got to make sure that you understand that the numbers ahead, the coefficients, are a, b, and c, and any signs go with them. So in order to graph a quadratic equation, a quadratic function, we need to know how to find the axis of symmetry. There is a formula for axis of symmetry. Write this down. So x equals -b over 2a. You can just leave the negative out front and you can use it at the end. But b over 2 times a. A lot of times it'll show it like this. You'll put a in parentheses. That's how that's going to work. So once we find the axis of symmetry, we can try to find the vertex. So that's going to be the minimum maximum. Another easy point to find is your y-intercept. And remember, once we have our axis of symmetry, if we find a point on one side, it's going to match on the other side. Now, I know that's not very symmetrical. I'm not very good at that. But if we find one on one side, it'll match on the other side. Okay, well, it says connect the points with a smooth curve. Y'all, mine look like these a lot of times, or it's crooked like that. So it doesn't have to be perfect. If you ever have to do it on the computer, it'll be perfect on the computer. So here we go, example 3. And so this is actually 2 pages. It's 2 pages in your book, and it's 2 pages on my sheet here. So here's step 1 and step 2, and then step 3 and 4 and the graph are on the next page. Okay, So I'm going to start here, and then when we get to the next page, we might flip back and forth a little bit. So here's our equation. Here's our function. We got to find the axis of symmetry. And like I normally do, I want to kind of not pay attention to this for a little bit. So I have negative b over 2a, right? So let me look up here. A, B, C. So what is B? B is 2. So I put a 2 there. What is A? I've got an invisible 1 right there. So I've got 2 times 1. Okay. So negative 2. 2 times 1 is 2. What is negative 2 divided by 2? Well, that equals negative 1. So x equals negative 1. That is my axis of symmetry, wherever you want to write it. Okay. Now, because the axis of symmetry passes through the vertex, I know that of my vertex, my negative 1 is going to be x, and I have to find y. I've got some x's here, so I can plug in negative 1 for x, because remember, this is just a replacement for y. Okay, so I'm going to plug in negative 1 for x, and I'm going to plug in negative 1 for x. I'm going to solve. Negative 1 to the second power, so negative 1 times negative 1 is positive 1. 2 times negative 1 is negative 2, and I'm going to bring down that negative 6. 1 minus 2 is negative 1. Negative 1 minus 7 is, minus 6, I told you the answer, is negative 7. So negative 7 will be my second point in my vertex here. So the vertex lies at negative 1, 7. Because A is, what is A? Let's look here. A is 1. That's a positive number. So because A is positive, the graph opens which direction? When it's positive, it opens up. So this vertex here is going to be if it's opening up, it's going to be a minimum. Okay, minimum. So our graph is going to look something like this. So we have our axis of symmetry, we have our vertex, and we know it's going to open up. So going on to the next page. Let's go ahead and plot our vertex because we know it, right? So let me write the information I know from this page. My axis of symmetry is x equals negative 1. My vertex is negative 1, negative 7. So I've got negative 1, negative 7. And I know the graph opens up. So let's do that. So I've got negative 1, negative 7. There's my vertex. I'm going to do a dotted line, kind of a really faded line, just so that you know this is going to be our axis of symmetry. It's going to be on there somewhere. Okay, so I don't know much else. I can find the y-intercept though. Remember, to find the y-intercept, you have to make x equal 0. So if we plug in 0, we can find the y-intercept. So x is 0 there, x is 0 there, and this is going to give us what y equals. Well, 0 to the second power cancels out. 2 times 0 cancels out, so I'm left with negative 6. So y equals negative 6. The y-intercept is negative 6. So I have another point I can plot. I've got 0, negative 6. 0, negative 6. That's down there, right there. 0, negative 6. Now I know because of this axis of symmetry that anything I put on this side, I can also put on this side. So this is half a square away from our axis of symmetry. So if I go the other direction, half a square away from my axis of symmetry, I'm also going to have that. Now, I don't know how far out I'm going here, so I can't really draw my graph yet because it could be a really skinny parabola or it could be a parabola that goes way out here. So I need to find another point. So let me do something like way out here. So I want to just plug in x equals 2. So if I plug 2 in for x, where did I get 2? I just picked it. I just picked 2. They picked 2. So if x is 2, what is y going to be? That's what we're trying to figure out right now. So 2 to the second power. 2 times 2 is 4. 2 times 2 is 4. Bring down my minus 6. 4 plus 4 is 8. 8 minus 6 is 2. So right now y equals 2. So I'm going to have x is 2, y is 2. That's another point. So if x is 2, y is 2. Remember, because of my axis of symmetry that I drew really lightly here, I don't want to make it too thick because it's not actually part of the graph, it's invisible. Because of my axis of symmetry, I can do another point on the same side. Remember, these are counting by twos, so I'm going 1, 2, 3 steps away. So I'm going to go 1, 2, 3 steps away here, and there's my other point. And now I can draw a pretty good graph. So there's my vertex. You want to try to make it curved, but mine always end up kind of pointed. Don't forget your arrows at the end. Ta-da! That's how you graph a parabola. Sometimes they might give you a table. They give you a table that's just trying to make finding the points a little bit easier. You could make a table yourself as well, but we still want to start with the vertex, finding the vertex and the axis of symmetry. So here's this. Okay, here's my equation. I know this is going to be A, this is going to be B, and that's going to be C. So B is -8, so I put -8 there. Don't forget this already had a negative, right? So this is -8. What happens there is going to cancel out. We'll do that in a second. A is 2, so I'm going to put 2 in parentheses. So I can go ahead and do this. Negative, negative cancel out. I'm left with 8 over 2 times 2 is 4. What's 8 divided by 4? 8 divided by 4 is 2. So my axis of symmetry is 2. I can plug 2 in for x to figure out what it is when it is y. So it looks right here, this one is going to be my vertex, because that's when x is 2. So this one right here is going to be my vertex when I figure it out. So I have y equals 2 times, I'm going to plug in 2 squared minus 8 times 2 plus 2. Okay, so 2 times 2 is 4. Negative 8 times 2 is negative 16. And then plus 2. Well, 2 times 4 is 8. Minus 16 plus 2. 8 minus 16 is negative 8. Plus 2. Negative 8 plus 2 is negative 6. So my vertex is going to be 2, negative 6. So here's 2. Go up a little bit. 2, negative 6. Here's my vertex. And I already knew that this is going to be my axis of symmetry. So I'm going to do my really light line there. I want you to be able to see it, but I want you to know that it is not part of the graph. Okay? My y-intercept is going to be when y is 0, what is x? So, when x is 0, what is y? So right here, this is going to be my y-intercept. So let's figure that one out. If I plug in 0 for all of these. So if I plug in 0 here, that cancels out. If I plug in 0 here, that cancels out. So what's left? 2. So my y-intercept is 2. So I'm going to come over here. There's my y-intercept. I know because of the axis of symmetry, when I have one point over there, I can put the same thing over here. So it is 2 steps, 2 steps. Ta-da! So my y-intercept is 0, 2. The vertex of the function is 2, negative 6. We already got those. So we can go ahead. You can find more of these if you want. We already found 4, 2 right there, 4, 2. Let's just for the heck of it plug in 1 and see what we get. Then we're going to find another point somewhere, right? So when x is 1, I'll write it down here. Y equals 2 times 1 squared minus 8 times 1 plus 2. 1 times 1 is 1. 1 times 2 is 2. There we go. Negative 8 times 1 is negative 8 plus 2. 2 minus 8 is negative 6. Negative 6 plus 2 is negative 4. Okay, so I've got 1, negative 4. That is 1 hop away. So I can go 1 hop away there. And look, 3, negative 4. They kind of match up, right? So let's look here. The parabola, let's draw my line, actually. Draw my U-shaped parabola. It's probably going a little too far in. It probably goes out a little more, but you know, I'm not perfect. So the parabola extends to infinity. That's why we have the arrows at the end. It says it keeps going forever and ever and ever. So the domain, remember that domain is my x value and range is my y value. Oh, here's the kitty. Go away, kitty. So the domain is my x value. What is happening to my domain? Eventually, this keeps going out and out and out and out and out. So it's on x. It's going forever. So that's, remember, what we call all real numbers. Now with the y value, it stops eventually, right? It goes on and forever up, but it doesn't go forever down. It stops at -6. So y is always greater than or equal to -6. Ta-da! We have one more example. We are skipping example 5, and we're going on to example 6. Now this might look a little crazy, okay? Most of the time when you have something like this, they're going to do the graphs for you, but not all the time. They might be trying to do a double whammy and try to get you to graph it and compare it. So this is comparing features of two functions. This is the function f of x. This is the function g of x. This is the graph for f of x, and this is the graph for g of x. Already I know, oh look, this is quadratic because it's a curve. This is linear because it's a straight line. I bet you it's going to ask about some of that here. Okay, so let's go. The function f of x it's a curve. It's in that form, so it is a quadratic function. G of x, I could look at that, or I could just look at the graph. It is a straight line, so it is a linear function. Okay, step 1, done. The x-intercepts. Let's look at f of x. F of x has two x-intercepts at -1, 0 and at 3, 0. Excuse me. While g of x has one x-intercept right here at -4, 0. So f of x intersects the x-axis more times than g of x. That's all we're doing here, is we're comparing these two. Neither one is more right or wrong than the other. We're just comparing them to see how they're the same and different. Now let's look at the y-intercepts. So the y-intercepts on f of x is right here at 0, 6, while the y-intercept on g of x is 0, 3. So we can just say the y-intercept on this one is greater, on f of x is greater than, it's got a higher number. It is greater than the y-intercept of g of x. Okay? Increasing and decreasing. So remember, we read graphs from left to right. So f of x, when x is less than 1, so here's 1. What is happening when x is less than 1? It is, from left to right, it is going up. It's increasing. Increasing. But when x is greater than 1, it is going down. So it is decreasing. G of x, if you read it from left to right, what is it always doing? It is always going up, so it is always increasing. Okay? Now let's look about when these are positive and negative. F of x is positive, so that means above the x-axis, for, let's see here, I've got -1, and I've got 1, 2, 3. So when x is greater than -1 but less than 3, the graph is positive. But it's negative when x is less than -1, and when x is greater than 3, then that graph goes negative. Okay? G of x is positive when x is, here's -4. It's when it's greater than -4, it's positive, and it's negative when x is less than -4. So when it's less than -4, it's going to go on the negative side. End behavior. So remember, we're looking out towards the arrows. What happens from the center point out? So as x increases, so going bigger, what is y doing? Or as x decreases, f of x is, it's decreasing both times. Both times. This is going down, this is going down. Both times it is decreasing. Now looking at g of x. As x decreases, g of x decreases. So as x decreases, g of x decreases. As x increases, g of x increases. Once you get good at this, you'll see the patterns, okay? Domain, remember domain is my x value, range is my y value. The domain, so x, it keeps going and going and going and going. X, it keeps going and going and going and going. So the domain of both of them is all real numbers. The range is my y value of f of x. I've got a top hat right here, right? It doesn't ever go past that. So what number is that? 1, 2, 3, 4, 5, 6, 7, 8. So when the range is when y is less than or equal to 8. So it never goes above 8. It always has to be less than 8 or equal to 8. The range of g of x, this y value, that is slowly going up, 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 up. That is slowly going down, 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 down. So the range is all real numbers for the linear equation. And that's that. 10-1. We'll practice on it tomorrow. If you are not done, or if you finish and there's still time, then go do Alex. Okay? See you tomorrow. Bye.